Everyone, today we are going to talk about ionic and metallic bonds. So, previously we mentioned two different kinds of chemical bonds, covalent bonds and ionic bonds, but it turns out there is a third way of bonding, and that's going to be metallic bonds. So remember that atoms will bond to fulfill the octet rule, right? They want to be quote unquote happy. So let's take a closer look at ionic and metallic bonds today. So just a review, ionic bonds are formed between ions from the transfer of electrons. So one atom is giving away electrons, the other is accepting it. These are formed between metals and nonmetals, right? So if you see a metal, then it's going to be an ionic or metallic bond. When dissolved in water, like if you dissolve salt in water, then it will give that water electrical conductivity. Okay, some other properties. Ionic bonds often form these crystal lattice structures. So if you were to zoom into your table salt, we would actually see repeating patterns of anions, that's the negative one, and cations. Okay, and they just continue to repeat, plus minus, plus minus, plus minus. All right, so this is the main thing for this lesson is how would magnesium bond with oxygen? So first, let's take a look at, we're going to draw the atom first. So I'm going to break this up into atoms, ions, and then formula. This is how it is on your worksheet as well. Okay, so first thing we want to do is figure out how many valence electrons are in each of these atoms. So we'll take a look at the periodic table. So magnesium, it's in group 2, so it's got 2 valence electrons. Oxygen, which is in group 16 over here, will have 6 valence electrons. So I'm going to draw those 2 valence electrons for magnesium and 6 for oxygen. Okay, and so remember that to fulfill the octet rule, atoms want to have either an empty or full valence shell. So what's going to happen here is magnesium is going to want to give away its 2 electrons. And so when it does that, it's left with 0 electrons and a +2 charge. Remember, we want to use brackets and a charge whenever we do the ions. Oxygen, on the other hand, will now have a full octet of 8 valence electrons, and because it gained 2 electrons, it'll have a -2 charge. When we combine these 2 ions together, they form the ionic compound magnesium oxide. Okay, so that's basically what you want to do. If you can draw the arrows, that's great. Otherwise, just make sure you're listing all the atoms and all the ions and the formula. You don't have to include the name. All right, let's do another example. What about sodium and nitrogen? So we'll follow these steps. And again, we'll do atoms, ions, and then formula. So sodium is in group 1, so it's got 1 valence electron. Nitrogen is in group 15, so it's got 5. So let's draw those out. Sodium has 1. Nitrogen has 5. Now, we can see that sodium can be happy by giving away this 1 electron, but nitrogen won't have a full octet. So what do we need to do here? Well, we're going to need more sodiums. So if I had another sodium, well, now this electron has a pair, and then if I add a third sodium, now nitrogen can be happy. So we're actually going to need 3 sodiums in order to fulfill nitrogen's octet. And so we get 4 different ions that result. We're going to get each sodium with a +1 charge, with no electrons, right? And then now nitrogen has a full octet. It's got 8 electrons total. And because it gained 3 electrons, it's going to have a -3 charge. And so the formula for that would be Na3N. So again, we're just trying to fulfill the octet rule. With ionic compounds, it does that through the giving away and accepting of electrons. Okay, you're going to have a few examples of these on your own, so hopefully you can get the hang of it. Okay, lastly, metallic bonds. These are formed between metals, of course. And so a sea or cloud of electrons surround atoms. More on that in a second. They are good conductors of heat and electricity. So that's why metals heat up really quickly. And they can also transmit electricity. So that's why we use metals in wires and things like that. Alloys are metallic bonds formed between different metals. So brass, for example, is zinc and copper. Sterling silver is actually silver and copper. Here are some fictional metals here: adamantium and vibranium, and then you got Mjolnir. So again, for metallic bonds, they are formed between a sea of electrons. So what I wanted to point out here is that the sea of electrons is basically the electrons move freely. Okay, so that's how metallic bonds work. They're what we call delocalized. And so this allows for electrical conductivity. All right, and that's it for